So here we are working to find the three x, y, and z that make these three equations with three variables true. As we do that, we're going to use matrices. So in matrices, remember, we're writing down all of the work, except we're not writing down x, y, z. So we're not writing down the y's or the z's or the x's. In fact, we're not writing the plus signs either, or the equal signs. So it saves us a lot of writing, and we can just concentrate on the row operations. So let's go ahead and write down the matrices. So we put the first column 2, 1, -4, then 3, -1, 3 to stand for the y's, -1, -1, 1 for the z coefficients, a dotted line where the equal signs go, -14, -5, 18. Then double check. Always double check. It's very frustrating to find you just lost a minus sign and you were doing fine except for that. Now, as you're working on these row operations, get a 0 in this first column as your very first thing, because you want your work that you do later not to mess up your earlier work and destroy zeros. So the idea is first we get a 0 here in the bottom left, and then another 0 in that column as well. So we want 2 zeros in the first column, and after that ideally we would get a 0 in the second column. So let's see how we can go about doing that. So since I want a 0 here, I'm going to take 2 times row 1 and add it to row 3, and then put the result in row 3. So 2 times row 1 and add that to row 3 and put the result in row 3. Now as you do that, you could make 2 steps out of that if you want to. You could do 2 times row 1 first. I'm going to try doing it all in one step, but then there's more chance for arithmetic errors. So if you keep finding you're making arithmetic errors, make 2 steps out of that. So 2 times 2 is 4, 4 plus -4 is 0. 2 times 3 is 6, 6 plus 3 is 9. 2 times -1 is -2, -2 plus 1 is -1. 2 times -14 is -28, -28 plus 18 is -10. And now I'm going to check all of that again in my head. Okay, that looks good. So now the next step is to get a 0 in the first column again. So right here. So I'm going to take 2 times the second row, add it. Actually, I'll take -2 times the second row and add it to the first row. That will give me a 0 right here. So 2 times row 2 and add that to row 1, and I'm going to put the result in this second row. So let's write the first row down the way it is. And let's write the third row the way it is so I don't mess those up at all. And even that I double check my writing, my copying down. Okay, so 2 times row 2, 2 times 1 is 2. Oh no, I said negative, didn't I? -2 times row 2. So -2 plus 2 is 0. +2 plus 3 is 5. +2 plus -1 is 1. +10 and -14 add to -4. And again, I go ahead and double checking showed that arithmetic's correct. Notice that instead of subtracting, I do take a negative multiplication, and that sometimes is a little easier than subtracting. Okay, so we have the 0 here in the bottom left, 0 here above that, so we have 2 zeros in the first column. Now we need a 0 in one of these columns. I cannot work with row 1 anymore. If I work with row 1, I'll have 2 added to these zeros, and it will mess that up. So row 1 is off limits. I'm going to have to stick with row 2 and row 3. So I think I'll go ahead and multiply row 2 by 9 and row 3 by -5. And then I'll have the same numbers here with opposite signs. So row 2 times 9, row 3 times -5. So I'm not doing anything to the first row. Row 2 times 9, so 0, 45, 9, negative 36, 0, negative 45, 5, and 50. And again, I pause and I double check my arithmetic. Well, that looks good. So I'll go ahead and add the 2 rows together and put the result in row 3. So I'm just going to put row 2 plus row 3 into the row 3. So let's just write down the first 2 rows the way they are. So adding the 2 rows together, we get 0, 0, 9 plus 5 is 14, 50, and negative 36 is 14. Okay, now we're ready to take these back out of the matrices and back into equations. So we have 14z equals 14. Divide by both sides by 14 and z is 1. And then the second row says 45y plus 9z equals negative 36. Since z is 1, that gives me 45y plus 9 is negative 36. So 45y would be negative 45, and y is negative 1. Then the first row says 2x plus 3y minus 1 is negative 14. So 2x minus 3 minus 1 is negative 14. 2x minus 4 is negative 14. 2x then is 10, and x is 5. Let's see. 2x is negative 10, and x is negative 5. Now, if you are going on into computer science, you'll see that they work these row operations even further. So if you're going on into computer science, you will only want a 1. You'll want this matrix to look like 1, 1, 1 with zeros here, 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 and here. And then over here would be the answers. You'd have, where's the x? Negative 5, negative 1, 1. So if you continue to do row operations on this, you will eventually get this look. You don't have to do that in my class, but you can see in computer science where you could aim for that by setting up operations on a computer that will automatically do this work for you. In fact, I did that I was a computer programmer for a couple years between my undergraduate degree and my graduate degree, and I had to do this for that.